Yeah, hello students. So last class we discussed um, in applied mathematics, we discussed some differentiation Euler's functions. So today also we are going to discuss about the functions. We discuss Fourier transformation and Z transformations. Okay, and inverse transformations in the last previous classes. Today also we are going to discuss about that maximal and minimal functions. So Seema will share that PDF. See here. So today we are discussing about the integral equations. So in the integral equations, so when we can say that the basic definition of the integral equation, so what is the integral equation means? So what is the meaning of the basic definition of the integral equation means? So so integral equation is an equation in which known as unknown function to be determined under the integral sign. So before that, so what is the integration? So integration means is nothing to summation. Okay. Uh, so why we are using the symbol of that integration means the first letter of S in the summation is S, no? So that S, this is the S. So just we are extending that S. So that's why we are using the symbol, the integration. So this is a symbol we are using the thing. So what is that basic definition of integral equation means? So using the integral equations, so we are determinate unknown functions in under the integral sign. So that is that integral equation. So basically the integral equation form will be, see this is the general form of the integral equation is, see this one. Linear integral equation is, so alpha x into and y of x equal to capital F of x plus lambda into, so k of x comma t and y of t into dt. Okay. Here this is the y of x function is there, no? This is unknown function. So we don't know that function. So this is that unknown function. So here the f of x and this alpha x. So this is the kernel of integral equations. So this is the k of x comma t. This is the known function. See, listen. Here that y of x is a known function and alpha x in and capital F of x is a kernel of integral equation function and k into x comma t is a known function. So this is the general standard form of the that linear differential, that linear equation, the basic definition of the linear equations. Okay. See here, some cases will be there. So I will explain the cases. Okay, see. So just now we are going to discuss about the Volterra integral equation. Volterra integral equations. Okay. See, just now we discuss. So just now we discuss about that integral equations. No? So what is the integral equation? That is alpha x into linear integral equation into y of x uh, and integration of, sorry. So capital F of x plus lambda into then integration of k into f of x comma t and y of t dt. Okay. So when we can say that it's Volterra integral equation means if the upper limit of the integration where integration is variable. So this is the lower limit and this is the upper limit. So this is the lower limit and this is the upper limit. So suppose this is a to x. Okay, na? So upper limit is x. X is a what is that variable. So now this is called what is that Volterra integral equations. See, once again I will explain. So what is the Volterra integral equation mean? So that integration of k of x comma t and y of t dt. Okay. So Volterra integral equation means, so here the integration part is there, this is the lower limit and this is the upper limit. This is the lower limit and this is the upper limit. So here, if that upper limit is a variable, if the upper limit is a variable, now this is called Volterra integral equations. So understood? So this is the thing. So there will be some cases will be there. Okay. Volterra equation of first kind. So what is that? Y the first kind. Okay, now so this is the one case. If alpha equal to 0, when the alpha equal to 0, so this is the unknown function is there, no? So it will appears only under the integral sign. So then we can write what is that if that alpha equal to 0. So when it is alpha equal to 0, so that is become f of x equal to, okay, and that integration part, that lambda into, so a to x k into x comma t and y of t dt. Okay, so this is called the first kind. Just we can substitute what is that alpha equal to 0 in the standard form. Okay, so this is the first kind. Now, if alpha equal to 1, so see here, so alpha equal to 1, so in the second case series of second kind, just we have to substitute alpha equal to 1. So alpha equal to 1 to here. So that is become y of x equal to, that is become capital F of x plus lambda into a to x k of x comma t and y of t dt. Y of t dt. So this is second kind when alpha equal to 1. Now let's see the third. Next thing, next if alpha equal to 1 and the capital F of x equal to 0. So then the equation is become y of x equal to, so lambda into a2x and k of x comma t and y of t dt. So this is called homogeneous Volta integral equation of the second kind. So this is a standard formula. Okay. So we have some formulas and we have some problems also will be there. So I will explain that formulas. Now we are going to discuss about the some formulas. So I will share the PDF. Yeah. So forming integral equation corresponding to the differential equation. Uh, the differential equation is d square z by dx square minus sin x into dz by dx plus e power of x into z equal to x. And with the initial condition, z of 0 equal to 0 and z dash of 0 equal to -1. No, see this one. That means, so this is x equal to 0. Oh, sorry, here see. See, z equal to 0 when x equal to 0. So this is z dash of 0 means z equal to -1 when x equal to -1. Okay. Now see here, d square z by dx square equal to yx. Now, by integrating with respect to x, so when you are doing the integration with respect to x, so the integration and derivation both are cancelled now. So we can get dz by dx equal to, we are integrated over the 0 to x, and the function is become that y of t into dt, and we are getting one constant, that is plus a. Okay. Now, already they given that then z dash of 0 equal to -1. So then we are getting dz by dx, then integration over to 0 to x, and y of dt equal to, that is -1. From there we are getting that. So again, we have to do the integration with respect to x. So if you are doing that integration with respect to x, then z equal to, and 0 to x y of t dt square, and one integration is become -x and plus constant b. Okay. Now here see, and when z of 0 equal to 1 no, so then we are getting the b value is become that 1. So this is the, so when you have z of 0 equal to 1 means x equal to 0, then z equal to 1. So when you are substituting the z equal to 1 and x equal to 0, and where we are getting that b value is the 1. So z equal to 0 to x minus t into y of t into dt minus x plus 1. Since the z of 0 equal to 1. The next, from 18, 19, 20, so all the values we should substitute. What is the d square z by dx square? That is y of x. And dz by dx. So this is the value, no? So sin x we write outside. And 0 to x, y of t dt minus 1. And e power of x, what is the z means? So this is, we got it, no? The z means 0 to x minus t into y of t dt minus x plus 1. And x, the right side part is the x. Now you simplify that thing, that y of x equal to x minus sin x plus e power of x into x minus 1 plus the integration 0 to x sin x minus e power of x minus t into y of t into dt. So it's represented the Wohlrausch integral equation of second kind 1. So this is become that, what is the second kind means? Y of x equal to capital F of x plus lambda into, okay, then k of x comma t and y of t into dt. Okay, so this is f of x. So this is that f of x. So this is f of x. And lambda is become 1. Okay. Then k of x comma t is become what is it? This is sin x minus e power of x minus x comma t into y of t into dt. Nothing here we did, ma. Okay. So once again I will explain. So first we are doing the integration with x, then we are getting dz by dx. So here the dz by dx value we can substitute and we are getting a equal to minus 1. Okay, that a equal to minus 1 substitute here and we are getting dz by dx value. Next again we have to do the integration with respect to x and we are getting the z. So that what d square z by dx square and dz by dx and z value. So all are we have to substitute in these equations. So then we are getting Oltra's integral equation of second kind. Then we are getting the capital F of x and so lambda equal to 1 and k of x comma t. See, so form an integral equations corresponding to the following differential equation with the initial values. Okay. So d cube z by dx cube minus 2xyz equal to 0. And with z of 0 equal to 1 by 2. And the z dash of 0 is also 1. And z double dash of 0 equal to also that is become to the 1. Okay. Same that every problem we should do the same things. Ma. So first we are taking d cube z by dx cube equal to y of x. Okay. Now integrate to the both side with respect to the x. So see the first derivation. So d square z by dx square that is 0 to x y of t dt plus a. So now that is the z of the z double dash of 0 equal to 1. No? So if we are substituting here that equal to 1. Okay. And this is going to the 0. So then we are getting a equal to 1. So a equal to 1. No? So the substitute that a equal to 1 here. Then we are getting. So then we are getting. This is d square z by dx square equal to integral of 0 to x y of t dt plus 1. So again, we have to do the integrations and that we can get dz by dx equal to integration of 0 to x minus 1 into y of t into dt plus x plus b. Again, we have that one integration is x. Okay. Next, and constant we are getting. So integration that is 0 to x is as it is when you are doing the integration. Here that 1 into dt. So uh, that we are taking that x minus t and y of t into dt. So again that see here dz by dx. So dz by dx equal to 1 when that z equal to that x equal to 0. So we have to substitute that. So that we are getting this one. So this is equation 23. So again, we have to do the integration. So that is become x minus 1 whole square, x minus t whole square by 2 factor into y of t into dt whole square minus x square by 2. X integration is x square by 2 and one integration is x and one constant c. So again, they given z of 0 equal to 1 by 2, no? So then we are getting z equal to 1 by 2 factorial 0 to x minus t whole square and y minus t whole square. Okay, this is the things. So this that every problem should be same thing. Let some different problem is there. So convert the differential equation y double dash x minus 3 into y dash x plus 2 into y of x into 5 sin x, and with the initial values is y of 0 equal to 1 and y dash of 0 equal to minus 2. Okay. Uh, Now the given differential equation is the given differential equation is y double dash of x minus 3 into y dash of x plus 2y of x equal to 5 into sin x. Okay. Now we have to do the integrating both side with given differential equation. So we are doing that integration of both side. So this is become y dash of x, and we are applying to the limits 0 to x. So that is become y dash of x minus y dash of 0 minus 3 into. Okay. So just I will do the problem. See, this is the problem. Y double dash of x minus 3 into y dash of x plus 2 into y of x equal to 5 sin x. And with condition y of 0 equal to 1 and y dash of 0 equal to minus 2. Now let's see the solution. So first thing, so we have to do the integrating with respect to x. So when we are doing the integrating with respect to x, so this is become okay. And from that is we are taking from 0 to x. Ah, so this is become C y double dash of x. So when you are doing the integration, that is over 0 to x. Okay. So that is become, what is that? Y dash of x, that integral 0 to x. So that is become y dash of x minus y of 0. So this is y double dash of x value. Okay. So from there we are getting, this is y dash of x minus y of y dash of 0. Okay. Plus 3 right outside. Then integration of y dash of x. So integration of y dash of x is become y of x. So that is become y of x minus y of 0 plus that integration of y of x is become, what is it? 2 into that integration of 0 to x, then y of t dt. Okay. Now integration phi right outside. Integration of sin x is, what is that? Minus cos x. That's minus 0 to 1. So that's become minus 5 cos x minus cos 0. That minus 5 into cos x minus cos 0 is minus 1. Okay. That was, from here we can write 5 into 1 minus cos x. So this is as it is will become here. Same thing. Okay. So here they given y dash of 0 equal to minus 2. So we can substitute here that y dash of 0 equal to minus 2 and that y of 0 equal to 1. So you should substitute here. Okay. So let's see what will happen. So this is become y dash of x. So here y dash of 0 is minus 2, no? So already that minus is there, that is become 2 plus 3 into y of x and y of 0 equal to 1. So that's become minus 3. No, sorry, this is the minus 3. So this is become minus 3 and plus 3 plus 2 into 0 to x y of t dt. Sorry, this is become dt. I wrote that. Yeah, equal to that right side part is 5 minus 5 cos x. Okay. This 5 is there, no? This 3 and this 2 and this going to cancel. So the what we are getting after the simplification, y dash of x and 3 into y of x plus 2 into 0 to x y of t dt equal to minus 5 cos x. So now again integrate so with respect to x from 0 to x. In, now, okay, and let's see. Now this is become what is that? Y of x minus y of 0. Okay, minus 3 into this is become 0 to x y of t into dt. Now this is become 2 into 2 times differentiation integration. No? So 0 to x and 0 to x y of t dt equal to see cos x integration. Cos x integration is sin x. So that is become minus 5 into sin x. Okay. So again, we have y of 0 equal to 1. Yes, no? So y of 0 equal to 1. So now if you are substitute there, y of 0 equal to 1. So, so this is become x minus t into dt. So that y of x minus 1. Okay. So now we could take the common of integral 0 to x outside. So that is become minus 3. For this one, that is become 2 into x minus t into y of t dt. 1 minus 5 into sin. Sorry, into sin x. Okay, now, therefore, then y of x equal to 0 to x if you are sending to this one here. So y of x plus, sorry, this is the plus. So 0 to x minus 3 plus 2 into x minus t of y of t dt equal to 5 sin x. This one no, so this come to that here. So that's become to the plus 1. So this is that integral equations. Okay. Yeah. Mm. So next problem, reduce the initial value problem y double dash of x plus lambda into y of x equal to capital F of x with y of 0 equal to 1 and y dash of 0 equal to 0 to non-homogeneous ultra integral equation second kind. So this equation we have to convert it into integral of second kind equations. Okay, see the solution. See, given that what we can write from there, y double dash of x, send this is to here. Otherwise, can send it to this here. So that is become y double dash of x equal to capital F of x minus lambda into y of x. Okay. So this is now what is the next step? So we should do integrating both sides. So with respect to x. Okay. No, that is y double dash of x. That is 0 to x. And that is 0 to x. F of x minus lambda into y of x into dx. Now this integration value is become y dash of x minus y dash of 0 y dash of x and y dash of 0 equal to 0 to x f of x minus lambda into y of x of dx. Now, so they given that in the question that see they given that y dash of 0 equal to 0, no? So we have to substitute there. here. So y dash of x equal to, so this is become 0. They given that y dash of x equal to 0 to x f of x minus lambda into y of x of dx. Okay. Now again we have to do integration with x. So that is the integration, and this is also integration, and this will become y of x minus y of x minus y of 0 equal to so this is become the function over that is become that 0 to x. So the function is completely changing, that f of t minus lambda into y of t that dt square. Okay. So y of 0 equal to the given 1. So y of x minus 1 equal to 0 to x f of t minus y into, sorry, lambda into y of t and dt square. Then y of x equal to 1 plus 0 to x, x minus t into f of t. This is, so when you are doing that dt square, f of t minus then lambda into y of t into dt. Okay. So this is that PI Voldra integral equations. Integral equation of second kind.